So we're going to take a look at the Chapter 5 log review, and let's make this a little bit larger. There we go. So the first thing we need to do is change to log form. So we can easily do that. What's our base? Well, let's switch that there. So we have log base 2 of 10 equals x. Change to exponential form, well, our base is 2 to the 4th equals x. And now we move into some where we have to evaluate. So let's see, if we evaluate this would equal some number. So exponential form, 5 to the x equals 125. Well, x, it has to be 3. So this evaluates and it equals 3. Let's see this one, it has to equal some value. So 8 to the x equals 1. Well, anything to the 0 power equals 1. The natural log of e, well, I'm going to rewrite that as log base e of x. Log base e of e, excuse me. So we have log base e of e equals x. So we have e to the x equals e. So once again, x equals 1. So this next one here, again, we'll set it equal to x. So we have 16 to the x equals 8. And since 16 and 8, they don't have a common base, so we'll have to rewrite it. So we have 2 to the 4th to the x equals 2 to the 3rd. So now we have 4x equals 3. So this would be 3/4. And then this next one here, I noticed that we have this exponent. So half, we can rewrite it as an exponent. So log base 5 of 625 to the half power equals x. So now if we rewrite it, we have 5 to the x equals 625 to the 1/2. Well, we have to write this with the same base. So let's see, 625. Well, 5 times 5 is 25. Times 5, 125, times 5, 625. Okay, so this is 5 to the 4th to the 1/2, 5 to the x. So x equals 4 times half, or x is 2. So it evaluates to 2. This one here, we need to condense it before we evaluate. So we have 48 divided by 3. So that'd be log base 2 of 16 equals x. So if we rewrite it, 2 to the x equals 16. So it would be 4. Now this next one is quite tricky here because we got a lot going on. And the first time I did this, I said, well, it equals x. So log base 8 of x equals log base 2 of x. And I was like, well, that doesn't help because our bases are different. I should say log base 2 of 5 here. So that didn't do any good. So I started thinking, well, what can we rewrite? Well, 8 is 2 to the 3rd of log base 2 of 5. And I said, well, okay, this does something here. This x number out in front becomes our exponent. So this would be 2 to the log base 2 of 5 to the 3rd. And I said, okay, well, I wonder what happens now if I rewrite it as a log. I know 5 to the 3rd is 125, so maybe let's rewrite that first. So 2 to the log base 2 of 125. And now if I wrote it equals x, I have log base 2 of x, log base 2 of 125, and we now have x equals 125. So this last one where we evaluate, well, let's take care of our exponents first. So this is 3 squared. So now we have log base 4 of 9, log base 4 of 8, minus log base 4 of 36. And if we have adding, that goes back to multiplication. So we have log base 4 of 72 minus log base 4 of 36. And well, subtraction goes back to division. So log base 4 of 72 divided by 36 is 2. So now if we write it equals x, sorry, running out of space here, we have 4 to the x equals 2. Well, it's the square root, so it would have to be to the half power. So let's take a look at some more of these here on the bottom half of this page. So we have to solve. So let's rewrite as exponential. X to the half equals 7. Well, this is kind of like the square root of x equals 7, so I know x has to be 49. This next one we could rewrite as an exponential, so 8 squared equals 2x minus 3. So 64 equals 2x minus 3. Add 3, 67 equals 2x. So x is 67 over 2. And then this last one is an exponential. Half to the 4th power equals 4 minus x. So we have 1 over 16 because both of those to the power of 4 equals 4 minus x. Minus 4 minus 4. So we have negative x, so that would be negative 3 and 15/16. And divide by negative 1, and we have x equals 3 and 15/16. And now this next one here.
Good morning, students.
Well,
All
let's see.
Honors English 10
We have a lot of natural logs here.
Class should
So
head to
adding
the
goes back to
auditorium for
multiplying.
speakers at 8:30.
So we have 2x plus 1,
Miss Wilford.
x minus 3.
Honors English 10 class
The
should
natural
head
log
to the
of negative
auditorium for
5x
speakers
plus 5.
at 8:30.
And now since they're all natural logs, 1 on each side, we know that 2x minus 1 times x minus 3 equals negative 5x plus 5. We can do some distributing. So we got 2x squared, let's see, minus 6x minus x plus 3 equals negative 5x plus 5. So 2x squared minus 7x plus 3 equals negative 5x plus 5. It's a quadratic, so we have to set it equal to 0. So that would be 2x squared minus 2x wait a second, this should be, oh, this was plus 1. Oh, that's going to change things. So we got plus x and minus 3. Sorry about that. Was going too fast there.
You ready for the quiz?
All right, so if we rewrite this now, we got 2x squared minus 5x minus 3, negative 5x plus 5. If we set it equal to 0, we'd have negative 2x, let's see, minus 5 plus 5x, plus 5x minus 5, minus 8 equals 0. So 2x squared equals 8, x squared equals 4, so x would equal plus or minus 2. But we always have to remember with logs, we have to go back and double check it. So if we had positive 2, I notice right here 2 minus 3 is negative 1, and that can't happen. Can't have that negative there. So it can't be positive 2. If we have negative 2, 2 times negative 2 plus 1 is negative 3, so we can't have that one, so there's no solution. And then write as a single log. Well, this number becomes a power. This number becomes a power. So we have log of x cubed minus the log of y minus the log of z squared. Subtraction goes to division, so we have the log of x cubed divided by y, log of z squared. Subtraction goes to division, so log x cubed divided by y divided by z squared. We could also write it as multiplying by the reciprocal, so log of x cubed divided by y times 1 over z squared. Oh, excuse me, times, 1 over z squared. So we have x cubed over yz squared. Because if you guys remember, fractions, when we divide by something, it's the same as multiplying by the reciprocal. The last couple on the non-calculator part here. So the first thing we're asked to do is find the inverse. So inverse, we change the x and y to log base 3 of y. But we have to solve for y. So let's see. Solve for y. X over 2 log base 3 of y. And then we could rewrite it as an exponential. So 3 to the x over 2 equals y. So 3 over x over 2 to the power of x over 2 is our inverse. And then it says evaluate the inverse at 6. So 3 to the 6 over 2, 3 to the third, or 27. Now the last one here, one last one where I have to find the inverse. So x equals 2e to the y plus 1. Divide by 2, so x over 2 equals e to the y plus 1. Rewrite as a log, so log base e of x over 2 equals y plus 1. Well, log base e is the same as the natural log, so the natural log of x over 2 equals y plus 1. And then we subtract 1. So the natural log of x over 2 minus 1 is equal to our inverse.